Okay, let's continue. So for the second half of the session, we will do some hands-on exercise using the Photo Studio to create geospatial visualizations and building HexTiles and playing around with H3. So I put up a link right here. We wrote up this tutorial walkthrough. If you scan this QR code, it will link you to this Google Doc. And you can keep it for your reference. Here we write out every individual step that we will go through during this tutorial. If anyone wants to follow up, you will need to create an account on studio.unfold.ai. And after you create an account, make sure to click the confirmation email link we sent to you and set up your profile. It's pretty simple. You only need to put in your username, your name, and a organization. In here, organization, make sure to use the IEEE Viz workshop. So we will add you to our workshop organization. Once you have done that, here is a link to a spreadsheet. This is the spreadsheet we will specifically create it for this workshop. So anyone who has signed up, you can put your user email that you used to sign up in this worksheet. We will make sure to share the data sets and map with you. This is important so that you can immediately start using Studio with the data set that we will be using in this workshop. Let me go back to this step. Give some time for people to set up an account. Nick will be here to answer any questions if you are working around answer questions if you're not able to create an account.
To read out loud?
No, it's on. Just read the question.
So we have a comment from Slido. I think the tutorial needs some access permissions.
Slide, okay. Let me check.
Thank you.
Are you on Slido? The tutorial or the workthrough doc? All right. And make sure after you follow the step to create an account, the last thing to do is to use this link in the tutorial session and add your email to it. So we will add you to a working group that we can share data sets with you. I will show the QR code again if you are trying to. Okay, if you're able to sign up, you should be able to see, go to Studio and Folder AI, you should be able to see this common interface. And here you should be able to see a toggle says IEEE Viz Workshop. So here are the maps that we created and data sets we can share with you for this workshop. So for the sake of time, I will start doing our first tutorial of a workshop by using one of the data that I created. So the first part of the workshop, I want to do a simple map creation for this one. This is a map that draws all the individual points of a river and spatial join it with elevation data sets, which comes in from HexTile. So for the first step, we can go to studio.unfolded.ai. Here in the data tab, make sure you're on the datasets tab. You will see a toggle says IEEE Viz Workshop. And we will using this dataset called China River Points. Check on it, and we can say create map. This will load the river datasets into the map interface. We can zoom in a little bit, and by default, because our dataset contains latitude and longitude column, there are in Mercator projection and the ID. This ID are for each individual river. I basically break them down into individual vet points. So the ID can be used to associate points into which river ID it belongs to. But at a glance, right now, we're looking at all the individual points on the rivers, and it's collected. I think I collected this data set from OSM. So we're drawing about 9,000 points in here, so it's quite heavy, but actually the interface is pretty fast because we're rendering on your local GPU. And now the second thing we want to do is we want to do some analysis with these individual, river points. We actually want to understand, whether which one of these are in a higher elevation, which one of these are in a lower elevation. So to do that, we will need to join these river data points with the elevation data. So we will click Add Data here on the top left, said Add Data. We can go to the data catalog. Here, because we want to join it with a elevation, we can just select elevation absolute. This is the HexTile we want to join our rivers with. And then we will do add data. This will load the elevation HexTile into our map. As you can see, these HexTiles are pre-built using the DEM data model that open source by NASA. So we built using the satellite imagery elevation data set and convert it into a HexTile format. So they can go pretty high res, but also when you zoom out, you can see it on a global level. We can see on the side panel, because we added the elevation data set, a HexTile layer is automatically created. We can shift a little bit to you drag this little handle here to move it on top of a HexTile. So now we're overlaying our points data set of rivers on top of the HexTile that contains the elevation data. The next thing we want to do here is that, okay, we have the elevation data in, we want to join it with our rivers points. What we will do is first, let's extract some tabular data from our HexTile. We have this little drawing tool here. So you can top right, you can click on the draw. Use this rectangle function and draw a rectangle that contains all our data points, river points. Here, then we can right click. There's one option here that says extract data. Once we click on that, a panel will show up. This one we said, ask us which column do we want to extract from our HexTile. By default, we just want all the column, which is only, in this case, only this one called max elevation. So we'll do confirm. And then another dialog shows up, asks us to name our extract data set. We just by default call it extract elevation absolute, and we will use the filtered viewport, and then we do extract. The reason we're doing this is because when we build the HexTile, our data is baked into this individual tile based on your current zoom level. To bring this data in to join with our rivers data point, we want to extract a certain viewport so that we can materialize these HexTile data into a tabular format. So now you can see on my side panel, I have this new data set called extract elevation absolute. And we can basically delete our HexTile now just to see what extracted data look like. So we will remove our original HexTile, say confirm. And then we can see now the extracted HexTile data is automatically drawn as an H3 layer because, and we can look at the table of what the extracted data looks like. It just has an index and then has an attribute called max elevation. So that's what this layer is currently showing. It's showing the piece of data, tabular data that we extracted from our HexTile, and then let's move our points on top of it. So here, each individual data points, it's materialize a tabular data set for us to join with. The next step we will do is, now we're doing our spatial join with all the points and to add elevation attributes to it. So we will click on this little overflow, select spatial join. On the left side, on the target data set, we have our rivers. On the right, let's select our extracted HexTile. And now because we have a Lalong geo column in the rivers data set and we have an H3 column in our HexTile, the spatial join automatically detect these two as the geometry column we can use to join and suggest that we should join with this intersect operation. Intersect spatial join allow us to attach attributes from HexTile that's projected where these points are projected within. So that's it. That's all suggested to you by default. We can just click run and wait for a couple of seconds. So here's a preview of our joint dataset. We can see on the left side, we have the original lat long and ID column from our point. And then we have an additional column being added to the points called mean max elevation. So the reason it's called mean is because we're doing a one-to-many joint, but in reality, because the HexTile does not overlap, for each point, you only have one HexTile that can be joined with it. So the mean of one HexTile of the max elevation will still be the actual elevation. Now we can do confirm because we have the elevation joined with our point data set. Okay, after we're doing confirm, let's hide our other data set. And we can see we have a new one called spatial join river with HexTile. Let's just make it a little more shorter name. Let's call it river with elevation. And we can see there's automatically a point layer created based on our river with elevation. And it finds that there is a column called mean max elevation. So here, it automatically uses the mean max elevation as the column to draw the color based on. That's pretty good. It's basically pretty close to what we want. We just have to do fine-tuning the look of this layer. So first, let's change our color scale. Because we're looking at a linear attribute called elevation, we should probably use quantize as our default color scale. And we can change the color to be something more linear. So I will change the step to 10. And then I will select a color palette, the vertex color palette, that's my favorite, to use a kind of dark blue to yellowish scale, where the darker color is, it's not projection, that's maybe something brighter for our projector. Still. This is better. Okay, so the blue one is where the elevation are lower, the green one are where the elevation are higher. And we can fine tune it saying I want the graphic to be a little crispier, so I'll make the radius smaller. There we go. There we have it. We have our rivers joined with a HexTile and then color them by the elevation that we bring in from HexTile map. Now, I was running this a little fast, but every step that I took is recorded on these tutorial walkthrough. So if you miss any step, make sure you can follow this to do the whole map yourself. It is pretty easy. I can basically do this map in like less than 10 minutes. As long as I have the rivers data set and load the HexTile in, it's pretty fast to get the map like this. Do we have any questions? Yes, I think we have a microphone somewhere.
Thanks so much. It's a great presentation and tutorial. I just had a quick question. Just to confirm, the purpose is to be able to understand the river systems and the elevation differences across these different river systems?
Yeah, so basically, when we do spatial analysis, a lot of time we're trying to combine the raw geometry with a table that has additional attribution. In this case, when we load the OSM dataset in here, we just have the raw geometry of the rivers. So it's a pretty standard operation where if we want to, say, find the rivers in a higher elevation, we have to join it with additional dataset that contains elevation. In this case, we did an exercise of bringing the world elevation dataset as a HexTile, join it with the raw reverse geometry so that you can do, so if you, let's say now we can just do filter, right? We filter on our rivers with elevation data set based on the elevation. And then we can say, okay, I want to show only rivers up to a certain elevation. I will just do filtering based on the attributes. And you can obviously do more, say draw a histogram based on distribution of elevation to see how many rivers are in a different elevation group. But this is an exercise basically showing how with HexTile we can easily join with any type of geometry to add additional attributes to your raw data set. Okay, that's mine. Nick has more exercise, exciting map to make, so I'll hand it to him.
Sound okay? Okay. There we go. Thanks, Shen. So I'm going to sort of continue the tutorial a little bit, working with some of the same basic principles. The first thing I wanted to do was give you a sense of making your own hex tiles. So obviously we have a bunch of large pre-built hex tiles. Building hex tiles is an offline process, but it's a fairly quick one for smaller data sets. The advantage of building your own hex tiles is that you can, you get easy access and fast access, multi-resolution data set. And it's easy to join it and work with other hex tiles along with it. But I'll also show you just how to convert a normal data set to an H3 bin data set right in browser memory as well. So to start with, I believe you should all have access to the SF Street Trees data set. So just to take a quick look at this data set, if we bring it into the map, when we select a data set and bring it into the map, it'll load the data set, it'll automatically create some layers for us, and we can quickly take a viewpoint, get a sense of what's in it. When we look at it, it actually creates two layers for us. It creates a point layer and it creates an H3 layer, and that's because this particular data set is already binned into H3. So if we look at the data table, we can see that it has both latitude, longitude, and then a H3 level 9 index. Now, one of the things we can do with HexTiles, since HexTiles is going to rebin, we now have two options for how to create the HexTile data set. So I'm going to create the HexTile data set back from this data set page. I can create it either from here, or I can click into the data set and click on this HexTile button. And that's going to bring up a quick dialog, and we have the option of either creating it from latitude and longitude, in which case we would pick latitude and longitude, or I can create it from H3 indexes directly. In this case, I have H3 indexes, but for many data sets that you would work with, you might not have those, so we'll try to do this from latitude and longitude. So I select the latitude field, I select the longitude field, I select the resolution. I already have an H3.9 version, but I can make a finer one here for HexTiles. So let's start by making an H3 resolution 11. It gives us the information that's about 2 square kilometers. 2,000 square meters. So you can choose, again, as I mentioned earlier in the previous session, you can choose the resolution that's going to make the most sense. Frequently, a finer resolution is good, but if you have to aggregate up, you might have some trade-offs between aggregating into a coarser resolution and losing some of the specificity of where the actual points fall. And then we choose our output columns. So you can choose any aggregation over your source data. There are several different ways of going about this, but the main thing I want is a simple count. So I can take the count, I can call this tree count. This is going to be my output column in my HexTiles. And just to give you a sense, I can, maybe let's take the mean age of the trees in that area as well. So I can choose different aggregation methods, put them together. When I hit confirm, we're going to start creating the HexTiles. And as I mentioned, this is an offline process. If we go back to this My Data page, you get this little orange dot. Might be hard to, you can see it pretty well in the projection. So I've got this new data set, this HexTiles data set, which I'm going to rename just to make it clear that this is the HexTiles. And it's currently building. And that'll take somewhere between a minute or two, sometimes longer for a larger data set. Rather than wait for it, we'll start the rest of the tutorial, and we'll come back to it when we actually need it in the analysis. As soon as we have that, we'll be able to see it. Let's just take a quick look if it's done yet. I don't want to wait for it here. So we'll continue and we'll come back to it after it's done. This is the one downside of this pre-building, pre-aggregation process is that it's not real time the same way that most of the things in the application are real time. Because you're not doing it in the browser, you're doing it as an offline process. The benefit is you can do much larger data sets than you would be able to do otherwise. In this case, the data set fits in memory. It's a little bit of a toy case, but we can handle significantly larger data sets than you could load into the browser memory. So let's move into the suitability analysis. And this is perhaps a more clearly analytically directed use case than some of the ones we've done already, in that we're trying to answer a very specific question. Suitability analysis, I'm not sure if you've come across it before. It's one of my favorite types of analysis because I'm not actually a data scientist, and I still find it very simple and straightforward to understand. Basically, you are taking a variety of different data sets. You normalize all of the metrics you're interested in usually between 0 and 1. You apply some user-defined weights to them. You add them all together and you get a score. And that score is representative of the combined value of those different metrics. So it allows you to do things like take diverse data sets that are not intrinsically related to each other, bring them together in a common unit of analysis, and use it to calculate a score that shows the suitability for some purpose. In this case, in this slightly imagined case, the purpose is going to be apartment hunting, because that's what I always think of first when I think of suitability analysis. But in general, site selection is a general category of data analysis that you might want to do to pick the best spot available for a new business, for a new program or intervention. There are all sorts of reasons why you might want to create a value surface over your map and choose the best spot for whatever you're trying to do there. When I go back to this data sets page, we can see that this HexTile, now it's green. If we look at it, it says that it's ready. And just to see what's there, we can create a map very quickly. And it'll bring in this multi-resolution data set. So we get a pretty coarse view, and then as we zoom in, it gets finer and finer, and we have a fine-grained map of street trees in SF. I chose street trees because, as I said, my imagined scenario here is that I'm apartment hunting, and I, for one, love to live on a tree-lined street. I find it to be something that's indicative of a much more pleasant neighborhood. And so that's one of the parameters that I'm going to bring in here. There are a lot of other parameters that you might want to bring in when you're trying to choose where you want to live. I only have some of that data available here. One other thing that you might be concerned about is you might be concerned about crime. So I have a crime data set that I'm going to bring in as well, somewhere. And you should all have access to this data set as well. This one is a point data set, and it represents, I think about a year of crime data for the city of San Francisco. So it's going to give us some sense of maybe where there are higher or lower crime areas. And we're going to do a little bit of processing to normalize it as well. and to bin it into hexagons. So the first thing that we usually want to do, and I walked through this a little bit in my previous talk, when I'm looking at a point data set and I want to get a sense of density, point data sets are not great for this. And it's particularly true for point data sets that are already aligned with something else. So you can see here that most of these are aligned with streets. They're probably based on street addresses. And so you probably have a lot of overlap. If you're familiar with scatterplots in general, but also scatterplot maps, overlap can be a major problem because you can't tell where there are many points versus where there's just one point. It can be very difficult to see. So the first thing I'm going to do to get a sense of the density of this crime data set is to bin it by H3. And as we saw, there's, obviously you can use this backend process to create hex tiles. In this case, the data set is also small enough so that we can simply do it right in the browser. So I'm going to go to this, this data panel. I'm going to select the data set I'm interested in, the SF crime data. And I'm going to add a column. So we have the ability in the application to create new metrics on the fly based on row level expressions. And so I'm going to make a new column that's going to index this to H3 res 9. And I'm going to type in the expression I need, which here is geo to H3, which I'm going to type correctly. I probably should have just copy pasted. I can click on latitude, longitude. One of the improvements in H3 v4, this is a total aside, but one of the most common mistakes people would make with geo to H3 is that they would switch the order of longitude and latitude. We expect lat long, many people put in long lat. So we actually renamed this in v4 to lat long to cell to make it extremely clear what the intended order was. But here I'm going to type that in. You can see that I've got my sample data over here on the side. I'm getting what look like good H3 values for my rows. I'll create the column. We don't make a default layer for this, but we can make one if we want to see what it looks like. One thing, though, is that while I've binned this data now, I haven't aggregated it. So if I bring in an H3 layer, I can see it, but what I'm seeing is an overlapping set of cells for every one of these points. And that's not really the kind of aggregation that I'm looking for. What I really want to do is to group my data. So I'm going to ditch this layer for now. And I'm going to go back to the column I made and select group by. And when I group by, I can choose the aggregation I want to use for all of my existing columns. So I'm creating a new data set where I'm grouping by H3. And in this case, all I really want to do is to count the number of crime incidents. But to give you, and so I'm going to unselect everything except for date time, which already has count selected. We could take almost any column because what we're basically doing is a count star. While I'm doing this, I'm always interested in seeing like the most common category as well. So I'll take a mode of the category as well when I run this. And I'll get this new data set, which only has the 3 columns that I identified, the group by column, the H3, the most common category of crime, and then a count of the crimes that are there. I still get what looks like a not very interesting layer right away, but that's because we haven't chosen to color it by anything. Sometimes we can pick something, sometimes we can't. Just to give you a sense, if I choose the category and then give it a good categorical ordinal color scale, you start to see the difference in different types of crime across the city. Almost all of these up here is larceny and theft. As I recall, what you get over here is other offenses, so it's other kinds of things. Sometimes that simply means that there's a smaller set of crime in other parts of the city. Sometimes that means that there just isn't, that you actually have other things going on. But I always think it's an interesting thing to see when you bin. Mostly when we bin and aggregate, we're thinking about non-categorical data. We're thinking about adding it up. But I find that looking at the mode also gives you in many cases, gives you a sense of how things are distributed across the city. But really what we're interested in here is count. And just to make this clearer, I'm going to rename that column where it says count date time. We can just call this, count of crimes. So I'm going to rename the column. Go back, I'll pick my count of crimes column. Now, of course, the ordinal scale doesn't make any sense at all, so I'll pick a slightly better scale. And now, this is a quantized scale, but maybe Jenks natural breaks will give us a slightly better view of the distribution. You can see, roughly speaking, where the distribution is. As we've discussed before, this looks a lot like a population map in San Francisco. Maybe that's not an accurate picture of where the most crime is happening that's going to affect me as a potential renter. So I'm going to add a population data set. Sorry, this one wasn't directly in the tutorial. I'm winging it a little bit, so bear with me. We have a variety of census-based population data sets here. I'm just going to take the age data set, which I know has a total population column. I'm going to add that. This is a HexTile data set. So, the good news is it covers the area I'm interested in. The interesting news is it also covers all of the rest of the area of the United States. So having these big pre-built data sets is a really good way to bring them in for whatever area of analysis you're interested in on the fly. It turns out that my area of interest is San Francisco, but I could do the same. I could use the same data set with no extra transformations for something like New York. So what I'm going to do is I'm going to join this with my crime data. And so what this is doing is basically sticking the column from the hex tiles onto the crime column, the crime data set that I've already created. I've got my H3 column in the crime data set. I don't need to pick an H3 column because it's going to pick one for me on the HexTile data set. And then I've got a lot of other things here, but the only one I really care about is the total population. I don't really care about age. Now I have my count of crimes. I also have a total population. I'm going to confirm that. And I can hide my HexTile layer. And what I really want to know is the normalized crime rate, the number of crimes divided by the population. So I'm going to make a new column for that. This is my join data set. Again, it helps to rename things. We give them default names, but that's not going to be always what you want. So I'm going to call this crime with pop. And I'm going to create a new column again. And I'm going to call this normalized crime. And I'm just going to take the count of crimes and the total population. And now I have these normalized crime values that go from no data at all to some higher values. And if I look at my table here, I can look at normalized crime. Hide some of these other layers. And that gives me maybe a little bit more nuanced picture of where crime occurs in the city. One thing that stands out here is that you've got high values for normalized crime over in Golden Gate Park, where there's very little population, but still lots of crime. Stay out of Golden Gate Park at night is the moral of this story. So now I have this nice normalized crime layer, and I have my street trees layer. But I might want some additional data here as well. And the great thing about suitability analysis is that you can basically bring in as much data as you like, as much data that makes sense for your analysis. So one other data set I'm going to bring in, which this is going to be in the Viz Workshop area. I have this transit proximity data set. This is a HexTile data set that I've built ahead of time. I'm going to add this. This has this sort of first order approximation of how close you are to different kinds of transit stops. And so making this, just to give you a quick sense, what I've done here is to take transit stops and then have a decreasing function out over the H3 grid. So this gives me a quick score of how close we are to a given bus stop or how close we are to a metro stop. For some reason, the data set here refers to a couple of these stops. I think the Caltrain stops as Metro. This is the OSM data set. And refers to the BART stops that you might be familiar with if you're familiar with the Bay Area as rail. So, the rail proximity is going to be really important to me if I want to get around on public transportation. And the bus might be important to me as well. So these are two new pieces I can bring in. I'll stop there in terms of bringing in data sets, and I'll move to the actual suitability analysis itself. So we could do this sort of on our own. The main thing you need to do with most of these is to unify the data. So now I have all of these different data sets sitting next to each other. And what I really want to do is bring them all together into one data set that I can easily use for suitability analysis. The requirement for suitability analysis currently in our application is that it needs to be an in-memory data set. So I'm going to start with, I think, my crime by population layer. Let's take a look at this. And what I'm going to do is basically join these HexTile data sets progressively to this layer so that I can get more and more data in the data table. So I'm going to start by joining, let's join street trees. I'll take H3 Res 9. I don't really need the mean age column. I'll just take the tree count. I'll confirm that. And then I'm going to sort of repeat that process periodically with my other data sets. I'm going to join it with transit proximity. And here I care about the bus. We said we didn't really care about the metro because that's not a transit system I'm going to use very much. I'll run that. Now I have these values for how close I am to a bus stop or a rail stop. I'll confirm that. You can see I'm sort of building up all of these interim data sets, each of which we could potentially use on their own, but which are building up into an overall data set that I'm interested in using. I believe I had, did I have one more? This is the point where I should have been counting. No, I think that's actually where we want to be. So I'll come back here. Now I have this join crime with population. I'm going to rename this to something slightly more useful. I'm going to call this our base data because this is the base data we're going to use for suitability analysis. And I can hide all these other layers. I'm going to call this layer base data as well. Again, just to keep track of where we are. Make sure that everything else is hidden. We could show all these layers, but in general, it's going to be easiest to do one thing at a time and hide the layers I'm not interested in. And then we're going to move on to the actual suitability analysis. So in the application, we've built out a couple of these analysis modules. This is something, from an application standpoint, something we intend to increase in the future. But one of them is suitability analysis. And the reason why this is worth building out a special module for is because what's really useful here is to be able to adjust the weights and see how things change in real time. So I'm going to take the layer that I'm interested in, which I've called base data, and it gives me all of the different parameters in my data set, all of the different metrics that I have here. And I can choose weights for each of them. I don't even need to choose weights for them to run the initial analysis. So if I don't choose weights, I'm basically treating them all equally and saying they're all good and we should add them all together in a normalized fashion. So they're all going to be from 0 to 1, and then I can get a score. But it turns out that when you're doing a suitability analysis, you don't actually want to treat all of them equally. You generally want to have a much more nuanced view of how each of them is going to feed into your analysis. And there are a couple ways to think about weights in suitability analysis. You can think of them as something that a user or a customer brings a priori to the conversation. In this case, I'm apartment hunting. I know which things matter to me and which things don't, and I can come up with some weights that are going to make sense for that. But in other kinds of analysis, you might be deriving those weights from from known data. So if I'm looking for a really good place to put a new store, for example, I might be deriving these weights by taking the same set of input methods and looking at my best stores that I already have and finding out what are the weights that are appropriate for them. So which things seem to matter most for those stores. Obviously, the more other comparable locations you have, the more that's going to be a legitimate process. But you might find that some of these are really important, some of them are less important, some of them maybe don't even belong in the analysis. In this case, I can start adjusting things, and I can see in real time how this is going to change. Now, those of you who've been playing along at home might notice that we have crime here, and that all of these things basically are being treated with a positive valence. We're saying that all of these things are equally good. Now, we could take crime down to 0, but that just means it doesn't occur at all in the analysis. So what we're going to do is we're going to change the min weight value. And we're going to change this down to -1 so that we can actually turn crime into something that has a negative valence. So now I can take crime and I can say, I really don't like crime. I'm going to count it against all of this. I also find that I have total population. That's not really something that matters to me in this analysis, so I'll take that out entirely. And I have counter crimes as well as normalized crimes. It's usually, if you can avoid it, it's usually not a good idea to bring in multiple metrics that are either derived from each other or that are very closely correlated, because they're just going to give you the same signal. You might as well choose the most important metric and assign a strong weight to it. Otherwise, you're essentially double counting something. So I'm going to take out the count of crimes entirely. I'll bump normalized crime all the way to -1. I'll bump up tree count. I think that bus and maybe to a lesser extent rail are important. Maybe I want to swap those in the Bay Area. So now you can see that things on the if you're familiar with the Bay Area geography and transit systems, now this is basically the line of the BART system. Looks especially strong. I can get a little bit more nuanced view by doing all of the same color manipulations that we have available for other kinds of layers. So I can get a different kind of layer. I can look at a different color scale if I wanted. I've got some additional ability to choose, for example, how I normalize. Right now, this is simply normalizing using range standardization, which is to say that everything is taking, we're taking the min and the max, and then we're doing a linear transformation to turn that from the min-max range to a 0 to 1 range. But I can also use Z standardization, which will give us maybe a slightly more nuanced view and is based on the standard deviation of the data. And when I hit confirm, now I have my new layer and my new data set. And as Shan showed, one of the most useful things here, obviously this gives me an overall picture, but since I'm actually trying to answer a very specific question, which is where do I want to live, I can start to filter down. I can add a filter on my suitability result data set that I've created doing that analysis. I now have this score column, which is represented here. And I can start to drag down. Oh, I still have the other layer underneath. You can see why these things are a little bit confusing. There we go. And now I can start to drag down and find the places that are really going to be most interesting for me according to the parameters that I've set up for this particular problem. And you can see that as we drag down, there's an area here, financial district, maybe not a great rental place. I probably should have put in something about apartment availability into my data set. But potentially, some of these other spots are starting to look pretty good. And I can start to narrow down my apartment search, which previously was spread out all over the entire Bay Area. We are extremely far ahead of schedule at this point. We thought this was going to take much, much longer. And so let me start by asking whether there's any questions about any of that and go from there.
All good? All right, great. Yeah, I was wondering if you had any methodology documents for your suitability analysis, like online?
I can do that offline. I don't have a. Yeah, we do have a use case write-up, but I think you're asking for paper and citation stuff. I can come up with that offline. I don't have one at the tip of my finger,
Okay.
but it is one of the sort of standard approaches. Yeah. Most of the standard approaches don't base it on H3 particularly, but it's in GIS textbooks as
Sure.
a standard analytical approach for geospatial analysis.
I guess a quick follow-up question. I saw that, yeah, you're using census data. You might have already answered this, but is it like aggregated by like block groups too, or what is it?
Yeah, so the original census data comes in. Let me just, do I have this here? Can't remember if I have a existing layer for it, but let me. There we go. Trying to get a nicer view of it. So the original census data came in as block group data. And I talked about this in the previous session, that what we did to create the overall HexTile was to take that block group data and then disaggregate it over the grid of cells. So basically figuring out how much of each block falls within each cell, allocating, and then allocating a portion of the data from the block group to the cells according to both the overlap of the block group with the cell, and then also, and I would have to look up exactly the parameters we used here, but also considering the building footprint, right, so that we allocated more to areas of the block group that had more buildings.
Great. Cool, thank you.
Are there any other questions or areas of interest here? I think I should ignore the temptation to do another ad hoc demo just because I can, and instead give you the 20 minutes. But I'm happy to talk to anyone individually, and I'm happy to go through the methodology that we've used here in more detail. Oh, there's another question in the back.
In a way, this is like a GIS. Do you have a repository of documentation on what types of analysis could be done? You've shown us a couple.
Yeah. So we do have a sort of full documentation site that for the application that goes through it. It is, we sort of go back and forth because it's not a heavyweight GIS system like ArcGIS or QGIS. The emphasis is really on fast data exploration and to some extent ease of use for less technical users. So my hope and our hope in general is in designing this is that, in addition to data analysts and geospatial experts, that some level of business user can also benefit from this, and at least to quickly create maps and view data, which, in my experience is actually something quite difficult for, a standard user with a data set of lat long points to actually do, whereas here we basically make it a drag and drop application. This is also, while I've shown you a lot of things that are specific to our application, you may be familiar with Kepler-GL, which this is based on. And so Kepler-GL has a subset of this functionality built in as an open source project. And there are, I believe, also, there's documentation for Kepler-GL, but also research papers, et cetera, that use Kepler-GL. So that would be another place to look for how to use this. And it's all built on top of WebGL-based rendering, which is why we can deal with these really fairly large data sets, things that, in previous eras when I started doing this work would have never fit into the browser. We can now bring them into the browser and render them very quickly because we're rendering, using WebGL and GPU processing. Sure, go ahead.
Thank you. So let's say someone's interested in exporting this data. Mm-hmm. And one use case that I see is, so I do all this analysis and I come up with some data, but then let us say the scale of this data is so big that I want to give an interactive use case to the end user. So instead of exporting a still image or a video,
yep.
What are some ways that I can export and make it into an interactive map?
Yeah, so that's a great question. So we do definitely offer data export. So if I wanted to take the results of my suitability analysis. I can export them from here. I can choose to either export an image or a video. I can export the data. I can export the map, but that's not going to be super helpful unless I'm loading it back into this application. So from an application and product standpoint, we offer the capability to have other users and to share things with them, just the same way that we shared data sets in this tutorial. You can share your maps and you can collaborate on them. We're in fact working on improving the collaboration features. The other thing that I would say is that you can embed. So there's a sharing possibility to publish the map, where it's basically served off our platform. And when you do that, I can simply do that now. I'll call this I won't give it a description. I have various options for what I actually include in the published map. I'll hit publish. When I do this, I'm going to get not only a full map that is publicly available to everyone who's interested in it, but also I can embed that in further applications. So I have an embedded version that basically has none of the Chrome, but still has the interactivity. I have this this public version, which I can share. And we also offer a set of SDKs that you can use to interact with that map once you've created it. There's a JavaScript SDK, which you can use to control an embedded map so that you can basically make your own Chrome around it. So here we have this, the same map now built out as a public map that anyone can access. So that's one way to share. So from an application and product standpoint, we've built a lot of ways that you can do this. From a end user standpoint, if you didn't want to be tied to the application, then maybe the video and image exports we offer or the data exports are the easiest way to get your analysis out.
Fantastic. And then I'm assuming there's documentation on how to use these.
Yep. Yeah, we have a full sort of video export functionality, and we have high-res images that we can create in the GPU and then export for you, and that's all documented in the docs. This is docs.unfolded.ai. I think that URL may change soon, but it's good for now and should be good for a while. Sure. Any other questions or comments?
Okay, so what's the strategy you have for getting new data sets in H3 format? It's like something you create at this time, like by yourself, right?
Yeah, this is a very good question because, I won't get into all the sort of business questions around it. I think that there's a set of general purpose data sets that we'd love to offer. Many of them we do already. So we have a full data catalog, which has, a set of data sets that we've put together from mostly OSM data, census data, public elevation data, other public sources. So these are things about infrastructure, landforms, land use that we think are generally useful. We are also, we started this, this application has now gone in one shape or another. Maybe this is unfair to say, but it's gone through 3 companies. Since Kepler GL was started at Uber, we leveraged Kepler GL to create Unfolded, and then Unfolded is now part of Foursquare. And so Foursquare has its own large data set of, both, it has a large data set of POI information, so, points of interest and lots of things about places all over the earth. And it also has data about human movement in aggregate, for the most part, that we can use to display. So, from some business standpoint, I think that those 2 data sets are probably going to be our next targets, because what we really want to see is that people can take this really amazing data set, put it together with our really fluid application, and quickly answer some questions that would have otherwise been very difficult to answer. But I think we're also interested in creating more data sets for the data catalog, particularly derived data sets. So One thing that's not in our data catalog, for example, is anything like the proximity data set that I built for the suitability analysis. But we've been working on a version of that actually uses routing-based isochrones. So what I had was basically grid distance from a transit station. But we would love to build out a data set that had actual travel time on roads from transit stations or from particular categories of POI. So those are also things that we're looking to build out. But it's a really good question, and we're definitely open for suggestion if there are other general purpose data sets. We'd love to include more weather data sets. We have weather in here, and it is, I think the challenge with weather is that because it has this temporal dimension, while we can leverage that temporal dimension, oh, this is the demo that I shouldn't do ad hoc, but I'll do it anyways. So we can create maps with a temporal dimension using our weather data set, and we can play them back over time. The first thing I do when I bring this in is to pick a different color scale, because I can't stand to see precipitation shown with a red-yellow color scale. So this is going towards what I was mentioning earlier, that we can take this temporal dimension of the data and display it. There's just, there's a huge amount of weather data, and it's very difficult to know ahead of time. And this is the problem with sort of pre-built data sets. It's difficult to know ahead of time what's going to be most useful to the end consumer. So at this point, we're doing it more on a sort of ad hoc basis. We're including this to show you what we can do in a temporal data set. We include it in the catalog, but it's only covering like the last 30 days in general. And it's only really covering a few of the weather metrics you might be interested in. So that, I think, is also a potential target for something we would include more broadly as a pre-built data set.
Maybe a second question, it looks very advanced, but there are so many things that can be done now. So what are the first priority things on your to-do list? That would be, because I have many possible questions what to ask, do you want to implement this or that, or what's the priority?
I'm laughing because I'm primarily an engineer, and so this is always my question as well to people on a higher pay scale is what's our top priority? And more broadly speaking, I would say you've basically identified the challenge of a general purpose tool. We didn't make this to fit a very specific use case. We made it to fit as broad a category of use cases as we could. And because of that, I think of this as, you have this sort of an area of use cases, and then you have these other use cases that are outside your area. And you have to figure out how do you expand your area in the way that's going to hit, either the most use cases you can or the most valuable use cases you can. In some cases, like with the suitability analysis module that I demonstrated, I think that we have chosen a use case that was a little bit further out, and rather than build a whole bunch of general primitives, we built a very custom thing for that purpose. And I think that that's probably going to be one of our next set of targets, is to build that out more. To be honest, because we're also an enterprise tool, and because we want to work with large enterprise consumers, I know for a fact that a lot of what we're doing is all the groundwork that you have to do to work with large companies. So, a whole bunch of integration questions and a whole bunch of data access questions. So one of the things we're really looking at is, how can I work with your cloud database in my cloud system? Or how can I work with your on-premises database in my cloud system in a way that, works for you, large corporation, and meets all your data privacy requirements and your security requirements. So unfortunately, there's a hefty set of work that falls within this sort of paying your dues category of engineering. Shannon, I don't know if you have comments too on what are the studio features that you would like to see? We'll have to switch mics in order to have Shannon answer. It can if they.
I'm the higher pay grade one that bring you to answer this question. As Nick described, but to me, the core of what we are good at is this high performance in-browser, fast pace exploration on large-scale geospatial data. So that is really the core of we were born from. Like Kepler GL is known for doing client-side GPU visualization on large-scale data set. So is Unfolded funding course, and so is why we are part of Foursquare. So I think even though there's a bunch of work being done so that you can do cloud data access or you can run on-prem, but the core of our founding principle is still doing this very smooth interaction, exploration, beautiful visualization, tailoring to movement data specifically, and doing all of that in browser. So I think that will still be the course of our next couple of years, and see how much we can do around there.
Hi, Nick. We have a question from Rob in Slido. Which strategies do you recommend to deal with polygon data?
Sorry?
Which strategies do you recommend to deal with polygon data?
For polygon data. That's a great question. And it really depends on what you're doing with the polygon data. So in many cases, I mean, I'm sort of the hexagon guy. So often the first thing I want to do is to convert everything to H3. It doesn't always make sense for polygons. And in many cases, a good example here is that polygons can differ vastly in scale, and sometimes turning it all into one small scale is appropriate. A good example here is often people think that they can just turn every county in the United States into some fine-grained H3 representation, and then they get to Alaska, and it turns out that they run out of memory. So sometimes polygons are the right choice. We do have, we have polygon display here. I don't know. Again, if I have it, I don't think I have a good data set at the tips of my fingertips already loaded that I can show. But we have layers within the application that can handle polygons as well as all sorts of other things. We have, just to give you a sense, we have points, arcs, lines. Shan showed some of these. We have polygons. We have clustering layers and heat map layers. So we can deal with polygons. We also have an increasingly large set of spatial operations that can work with polygons. So Shan demonstrated this with H3 cells, but we can also do things like join points with polygons and transfer the data from polygon to a point it contains using a set of really fast in-browser operations that we've built. And so usually I'm doing that. The most obvious thing to do with polygons is choropleths, and that's good up to a point, but you also end up with the key problems of choropleths, which are mostly that they overstate things by area. If area is your main consideration, then that makes a lot of sense. If area is not an important consideration for you, then it might make more sense to transform your polygon data into something else so that you can see things on an even footing. Sorry, it was a relatively general question, and so my answer is sort of all over the place. But I think there are a lot of things you can do with polygon data, and it does give you really crisp edges and really well-defined, highly detailed representations. And we can handle it pretty well. We can also deal pretty well with 3D because we're doing this all in the GPU. We can extrude your polygons and show things like building heights or other kinds of things where 3D might be appropriate. It can be visually very difficult to deal with, though, I think, when you start going beyond choropleth representations and polygon data.
So we also have a follow-up comment from Rob. So he's saying, I'm currently using an intersection between the H3 polygons and polygon data and a calculation using the area of small parts to get an accurate representation of the original file.
Yeah, so I think that's one. The way to go between H3 and polygons is really going to depend on your use case. There's not one right way to do it. One way that we've used has been to take a very fine-grained H3 resolution and count how many of those fall within a given polygon, and then aggregate up so that you end up with coarser data that counts the number of smaller data elements within. That's one option. One option when you're disaggregating polygons, as we said, like the easiest option when you're disaggregating data, like from a block group, for example, into the H3 grid, the easiest option is basically to take the easiest option is to take the polygon data, divide it by the number of cells, and then stick it into each cell. That's not always going to make sense. So frequently you then want to apply some kind of per cell weight, which might be the percentage of the polygon, or percentage of the cell that falls within the polygon, for example, and do a weighted disaggregation that way. But even then, it really depends on the data. Some data is going to make sense to disaggregate by essentially dividing it, and some data, if you have some average or continuous value, maybe it just makes sense to copy it to all of the cells that are within that polygon. So it really depends on the use case. There are many different ways to go from H3 to Polygon. I think I have a notebook for this that's not part of our application. Sorry, I'm a big fan of Observable for notebooks. I believe one of the H3 tutorials, which I believe I mentioned earlier, is about using polygon layers. So this sort of demos how I might take an initial set of polygons and then break it down to H3 at different levels. So it also depends on the resolution of H3 you're dealing with. If you're dealing already with a very fine-grained, much finer grain of H3 than of polygon, you might simply use a standard like polyfill operation, how many cells are within that polygon. Any other questions? It appears that this meeting, like all meetings, is expanded to fill the time allotted, so thank you for that. I appreciate it. And thank you very much for your attention.